There we go. Okay, so many apologies for the network issues last week. I got a new desktop, I don't know, about 6 months ago, and the onboard Ethernet really wasn't working right. I was always getting like a super slow upload speed and a normal download speed, and I worked with the company to try to fix it, and no luck. So I got a separate adapter that plugged in via USB, and that worked really well up until last week's class. And then it just kept disconnecting. I don't know if the USB connection itself was loose or what, but now I switched back to the onboard one and magically it's working just fine. So I'm going to stick with the onboard one. Hopefully that'll work. So if anybody has any questions on anything along the way, please let me know. Any questions from last week? Deafening silence. I'll assume that that's a no. But again, if something comes up and you have a question, let me know. Let me. Can everybody give me hands up if you've done Java before, or if you feel comfortable with Java, let's say. Okay, that looks like everybody. That's excellent. I don't like to assume that for this class, but that'll make the comparisons that I do against Java more meaningful. But again, if there's something that I mentioned that you haven't done in Java, and I'm talking about Java, let me know, and I can map it some other way. So, to continue on from last week, I'm going to talk about control structures first of all. And we're still going to keep doing this in this single main function. And then we're going to move into talking about how you write separate functions by themselves, do some fun stuff with recursion, because recursion is always fun. And then, let's see, what was the other thing? Was my little to-do list that I had here. There we go. Let me get rid of a couple of files that are open that are getting in the way. That's better. I've got another thing off on the side of the screen here. Okay, so let's first of all talk about conditions that you can use inside your applications. We're going to start off with a couple of vals here. X is 10 and Y is 20. So what are the types of X and Y here? Anyone? Integer. Yep, those are integer types. If I put an L on the end of it, that makes it into a long type. If I put in a dot and then some number like that, that makes it into a float or a double. So these normally you're not going to have to specify the return types, but if you want to be explicit, you could put them on there, just like that. And you'll notice that it's putting them in gray. And if you float over that, it's telling you that's redundant. You don't have to do that. Doesn't mean you can't. But depending on your company, you may have some standards in place and a style guide that says should you be explicit about it or should you not be explicit. And sometimes there's some rules upon when you want to be explicit and when you don't want it. In this case, we're going to use the implicit typing here. So we have X and Y as two values. That means in this particular case, these are immutable. You cannot change them because they do not have a setter associated with them. So what we're going to do is we're going to use these values to create a new value. So I'm going to say val result equals if X is less than 10, then I will say low, else if Y is less than 10, medium, else whatevs, something kind of like that. Now this is an interesting use of an if expression. The if construct can be an expression or you can use it as a statement. If you use it as a statement, you're just ignoring a result. And the difference is if you use it as a statement, you don't have to cover all cases. You'll notice in this particular example here, I'm covering all possible cases here. I got an if here that'll resolve something, an else if that'll resolve something, and then any other possible value is covered. And if I didn't have that any other possible value, you'll notice that the low and medium are getting squiggles. And oh, that's interesting. So this is going to be an interesting way to look at this. Basically, the result has no value. So what happens is the result here is going to be set to, boy, what is the result being set to on this? I would have thought that this would have told me, hey, you can't do this. This is interesting. Let's find out what result is there. It might be okay because the X and Y are resolvable at compile time. Just to do a little test in this, I'm going to move them outside of here and change these to vars. And let's see if it still gives. Oh, was it actually highlighting that before? Oh, it was. I'm sorry. So this if here, if we float over this, it says if must have both main and else branches if used in an expression. I missed that before. That's really what I was looking for. So in this particular case, I haven't covered all possible conditions. Therefore, it can't properly resolve the type of result. And there may be cases when result wouldn't have a value, which is illegal. That's what I was looking for. This cast was interesting because I'm just kind of wondering what it's actually thinking the value could be, but because it's an error, it really doesn't matter. So that's just an interesting way the compiler is doing that. Now these other squiggles here where x is less than 10 and y is less than 10, these conditions are always evaluatable by the compiler, because the compiler says these guys are values. They can't possibly change while things are running here. Therefore, when I get into here, this is already known at compile time. This is already known at compile time. Now, what we're going to do to make that not be an issue is I'm going to move these values out of the main, which still doesn't change these, because you're going to see that because they're immutable, it still knows at compile time what their values are. If, however, I make this a var, then those little squiggles go away, because now something else might modify those while this main function is running. We don't have any code that currently does that, but if I had another function in here that says x equals 100 and have something set up to call foo, I'm not going to talk about that right now, that would have to be something either main calls foo, or there's a coroutine running, something running asynchronous here to run that. What Kotlin is doing here is saying, okay, I no longer can make that assumption, therefore them checking at this point is perfectly fine. If I put that guy back in, I get no squiggles left, because now all my cases are cut, well, except for whatevs not being a word as far as the compiler is concerned. So now we've covered all of our cases on this result, and we can print the value out. When we print this out, what do you think we're going to see? Any ideas? That sounds right. Let's go ahead and run it just to make absolutely sure. And hello. There we go. Whatevs. So it's exactly what we thought it was going to be. Okay, so that's a basic if expression. Now, if I took this same code and used it as a statement, notice now it's giving us some warnings here. And these warnings are basically saying, hey, you've got a value here, but you're not doing anything with it. This is unused. What we need to do in this particular case is actually do something with it. Up here, these values were being assigned, so we're actually using them. Here, we're not doing anything with them. So if I just put in printlns around each of these guys, now it's happy because we're actually doing something with these. And if I run this, I should end up seeing whatevs printed twice. Let me actually move this guy up here. There we go. We got whatevs printed twice. That's nice. But now in this particular case, I don't have to cover all the cases. I might not want to do anything in the other cases. So in this case, I should only see whatevs printed once. There we go. So depending on how you want to use this, as an expression, you have to cover all the cases. As a statement, you don't have to cover all the cases, but you have to do something inside each of those with each of those values. Now suppose I did something like that, where I'm commenting out the println low. This is still valid. I don't have to do anything inside the curlies. It's just an empty expression. And sometimes you'll want to do this. Sometimes it's a little more obvious if you do that kind of a branch and have a comment saying, I really don't want to do anything here. Otherwise, you probably want to just invert the values. So in here, we could convert this to a if x is greater than or equal to 10 and that. And then we'll end up getting the same result. We didn't do anything with that x is less than 10 value, but now we're covering that other case here. So you can mix and match like this, and I'm sure you've done things like this in Java and other languages. So I will not dwell on that. Okay, so that's our basic if statement. Now, when you start getting multiple branches like this, sometimes the code is less easy to read. And what we'd really like to do is be able to come up with a expression that will be more readable and a little bit easier to use in general. So what they did in Kotlin is they came up with this thing called a when expression. So I can say val result2 equals when, and then have a condition and then a value. So I'm going to recreate the same code in a when expression here. So I'm going to say when x is less than 10, then I want the value to be low. When y is less than 20, or less than 10, we'll have it be medium. Otherwise, we're going to say low. Now notice that before I change that to an else, it's coming up here saying that this expression is always going to be false. And the reason for this is that these are evaluated in order, just like these if conditions were. So we had x is less than 10, y is less than 10. So if we got this far, we know for a fact that x cannot be less than 10. Otherwise, we would have handled it. So when we get to this place here, he's basically saying, yeah, that's always going to be false because I already know at this point. And this is something that Kotlin does really well with its validation of the code that you're taking a look at. In some cases, it gets even smarter than this, and it uses things they call a smart cast. So if we were using object-oriented programming, which we'll get to later, it will take a look and say, hey, at this point in the code, I know for a fact that this variable has to be a certain type. Maybe you did some type checks before it, and it can assume inside the block of code that that's the case. And this is super, super helpful. This is kind of a slightly boiled down version of that, where it's just doing analysis of the conditions and says at this point in the flow, there's no way for this condition to hold. And that's really nice because then, if you made a typo, you might be able to catch it more easily. So I'm going to go ahead and put this to an else. Note that the when here is not exhaustive. If I flow up here, he's saying that there's something missing. There's possibility for me to not have a value to set to result2, just like we did before. And so in that case, this is where I want that else to be. Whoops. And once again, depending on what you put here in your code, you could have an explicit condition that happens to cover everything. Let's just see if it'll pick this up right. So if I say if x is greater than or equal to 10 and y, is greater than or equal to 20. Boy, my fingers are going to have a nice night tonight. I can see that. So if I do this, yeah, he's not really picking that up. So less than or equal to 10. Let's see, is he going to pick that up now? Condition is always true. Yeah, see, that's interesting that it's actually picking up the condition is always true, but still not picking up that it's exhaustive. So I wasn't sure if it was going to handle that or not. Always worth a try just to see what's going to go on there. So just to keep the compiler happy, we throw in this else, and he's like, oh, okay, yeah, I'm good here. So that's a great little expression. And once again, you can use that also as a statement. So if I come down here like this, right, once again, it's telling us these guys are unused. That's why they're squiggles. So we're going to actually do something with them. Oh, wow. There we go. And there we go. And so now that's fine. So this is a statement versus expression. Put him up there. So you can use both. It's very useful in a language like that. Use these as expressions whenever you can. I mean, it really can clear up your code. And when you're assigning variables, this, I believe, is much more readable than if we had it in statement form, kind of like this. If I said var result A equals 0, and then did what you'd have to do in Java, something kind of like that. Oops, I made it a val. You can see how accustomed I am to making everything be immutable if I can. Now take a look in this particular, whoops, they're strings, aren't they? Yeah, there we go. Take a look in this particular case here. This is equivalent to this expression up here, but there's a lot of redundancy. You say result A equals, result A equals, result A equals. And so what Kotlin's going to do, if I float over this if, he's going to say, hey, you can lift that assignment out of the if. And let's see what that does. I'm going to make a copy of that block. Notice the light bulb here? If I click on the light bulb, it's going to give me an option to lift the assignment out of the if. And it's showing you over here what the code's going to look like. Result A equals blah, 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 blah. I can also, if I'm on that line, hit Alt-Enter to do the same thing as clicking on the light bulb. And so now I'm going to hit Enter on this, and boom, I see result A equals, ta-da, all that stuff. So it's reducing our code, simplifying it quite a bit. So we don't have all these redundant result A equals, result A equals, result A equals. Okay. Now, if you're not using result A anywhere else, then you could just go ahead and say val result A equals, and guess what? We're back to what we had right at the start up there. Okay. Now we can also use a when expression to check values of things if the values that we're checking are all the same. Now we'll notice in each of these when expressions, the conditions are unrelated to each other. So we have a condition here of x is less than 10 and y is less than 10. Those have no relation. We're not checking the same value. If we were checking the same value, then we can use a shorter form of the when statement. So I can say when, well, let's make a val result 3 equals when x plus y. And what we're going to do is just take a look at this value. It could just be when x or when y, that's fine. Or you can have any expression you want inside there. And we're just going to check the value of that expression. So I can say 20 foo 25 fee 30 phi, and then else, oops, oh, come on, bye. And in this particular case, what value we're going to get out of this? We're going to get the 30, right? At least we should see phi, I believe, because we had 10 and 20. Yeah, okay. Unless somebody else has changed things. This version of the when doesn't require you to basically say x plus y equals 20, x plus y equals 25, x plus y equals 30, or so on. This is a slightly shorter one, but it only works if these conditions are all based on the same value or the same value computation. Now, what if we wanted to print the value? Or actually have that be part of that string. In this particular case, we need to somehow capture this value so that we can print it out. And what we can do there, I'll go with result 4, is actually define a value inside of here. So I could say val z equals that. And now I have something that I can grab a hold of and I can use inside any of these conditions. So I could do something kind of like this. Value is $z. And this will actually give us whatever the current value is. So in this case, I'm going to get rid of that 30 clause there. And let's do a println result 4. And we'll run that, and we should see by value is 30. There we go. Printed that guy out there. So that can be really helpful there. Okay, any questions so far? I'm sorry, one more time. Mm-hmm. Oh yeah, you can do. I'm sorry, that's actually a good thing to do there. So let's say that we wanted to print out some logging or do something else there. We can actually have that be a block like that, and then put in here a println value was 20, and the block acts like a single expression. So it'll perform all the code up to the very last expression, and the last expression is what gets returned. Something like that. So the block itself is an expression. It's not just a grouping of code. And this way we'll see that foo could be returned, but we can still do other things in there as well. Did I interpret that question and answer it properly? Excellent, excellent. Yeah, sometimes I'll hear something that's not there. Sometimes I'll be like, oh, I think this is the right answer, and I'm like answering a question that wasn't asked. But good, yeah, I'm glad you brought that up because this is actually very, very valuable to be able to do things like this. And if you had this as a statement, you wouldn't even need to have an expression that returns anything. So if I did something like this, I could just have it maybe print a couple things. What I was expecting, value was 20. And we could do something similar with these guys here. Oops. Something kind of like that. And you can mix and match these. You don't have to have all of them be curlies, but if you do need to do more than one thing, just put curlies around them. Okay. Now, when you have something that's an expression, that expression itself could be used as an argument to a function, and we'll see that a little bit later. So just kind of keep that in mind. We don't have to assign it to a variable and then pass the variable in. We can just pass this in into a function call directly. And we will see some of that a little later. So you can do some really neat things with that. Okay, so let's take a look at some other types of control statements. We already looked at assignment last week. Let's have, sure. Um, for for less than Yeah, for less than, that won't work. So if I tried doing that, that's not going to work. You'd have to use the explicit format without having the expression come in there. I think we might be able to say Z there. No. So what's happening here is it's expecting the values that are listed here to all be integers or an else or an explicit else there. And when I said Z is less than 20, this expression Z is less than 20 is a Boolean expression returning true or false, and it was just expecting to have an integer there. So that unfortunately doesn't work. There's a few things when we're dealing with objects and nulls that are a little bit more flexible, where you can actually check to see if an object is of a certain type versus having a specific value. But for primitive values like integers, no, it wouldn't work here, unfortunately. So you'd be stuck with this kind of a format up here without the value being passed in. Okay, so those are whens and ifs. Let's go to a new file over here. And inside here, let's talk about walking through loops of things. So let's do a val x equals 10, val y equals 20, var z equals x plus y, something kind of like that. And let's do some things with this. Now, as we saw before, we can change the value of z, maybe make it x plus 10, because it's a variable in this case. We could also do the z plus equals 10, which is the same as z equals z plus 10. So it's just a nice little shorthand. And that'll work for any of the arithmetic expressions, times, divide, minus, and plus. I believe it works for mod as well, which is the percent operator. What we're going to do now is walk through a bunch of different types of lists and items in a list. So I'm going to define, first of all, a list of strings. So I'm going to say val list equals list of A, B, and C. And we're going to get into a lot more detail later on exactly what a list is. Whoops, I have got somebody coming in. There we go. We'll go through in a lot more detail later exactly what a list is, and especially when we start talking about generics, we'll get into more about the types. But just think of this as a bunch of items you can walk through, where the first item has value A as a string, second has value B as a string, third has value C as a string. And the list of operator will create a immutable list. Now, that's a little untrue. I'm going to be a little bit weaselly on the words here. Because what it actually does is create an array list, which is something you could change if you cast it. But the type that you get over here, if I float over here, we'll see is list string. And the type list doesn't have any ways of setting values. It just happens that behind the scenes, it's a list that if you cast it to something else, you could modify it. There are ways around that we'll talk about later, but for right now, let's consider this to be a list that we can't modify or is going to be very difficult to modify. Now, for each of these items, there's a bunch of different ways to walk through it, and we're going to start off with very simple control structures here in the language itself. So we're going to say for n in list, actually let me call that item in list, println item. Now this for loop takes a variable that's going to walk over some values here, and then we're going to print the values out. So what we should see is A, B, and C printed on separate lines when we run this. Oops, I ran the wrong one. Let's run this one. There we go. So we see A, B, and C run 1, 2, 3, kind of like that. And this is just saying walk through each of the items in the list and assign n to each of those values as we're walking through, or item to each of those values. Now what I could also do is say for n in list dot indices. And indices creates a range. This range, if I did something kind of like val range equals list dot indices, we're going to see the type of this guy is going to be an int range, and that keeps track of a lower bound and an upper bound, and whether or not the upper bound is inclusive or not. For this particular example, the upper bound will not be inclusive. So this will actually give us a range where the lower bound is 0 for the first element, and the upper bound is 2. Well, the upper bound is going to be 3, but it's marked as exclusive. So we go from 0, 1, 2. So each time through this loop, n is going to have the value 0, then 1, then 2. To use it, we're going to have to use a array de-indexing syntax. So I'm going to say println list sub n, and that'll work. Both of these are going to print out the exact same result. I'm going to get rid of that line. So if I run this, I should see ABC printed twice. There we go. Something kind of like that. Depending on what you're trying to do, if you needed to know those indices, you could use these. Now, unfortunately, the first indexed item is 0. And I think this is a horrible mistake in computer science. The early languages treated 1 as the first item in the list. And then when we got into languages like C and C++, where they decided they're going to do some shortcuts for direct memory addressing, where basically if you say x sub 0, what you're really saying is find the address of find the thing that's at address x, and then move 0 bytes from it, or move 0 chunks of bytes, depending on what the type is that you're dealing with. And I think that was a horrible, horrible mistake. But unfortunately, it's taken hold, and pretty much every language that's a modern language is using 0 indexed ones. And it's very similar with graphics. If you're dealing with drawing things on the screen, we're dealing with the upper left corner as being 0, 0, and then as you go down, y increases instead of going up. And that's very much against just the pure math concepts of things. The reason for that one, of course, was we had cathode ray tube monitors. And the cathode ray tubes would start their scan in the upper left, go across the screen, then move a line down, then go across the screen and move a line down, and so on. So we have a few unfortunate artifacts left from the ways that old languages were implemented, but probably everybody's used to it. The only problem with it, or the big problem with it, is that it tends to result in a lot of confusion on how do I walk through things? What's the last item? And you get some functions who define things like the last, when I'm walking through, I'm going to walk from 0 to the end number. Other ones will be 0 to the end number minus 1. So sometimes you have some confusion in how functions are written. Make sure you check the documentation when you're running your functions or calling your functions. Okay, so there's that guy there. Now let's do something a little bit more explicit. I'm just looking at my notes here, and I had the same function written twice. That was silly. Let's actually define a range ourselves and then walk through that range. So I'm going to say for n in 0, ... 10. Now notice the little assist here that IntelliJ added for us with this less than or equal to. That's not normally there. So if I comment this out, this is actually what I wrote, 0, ... 10. When you have that 0, ... 10, you're defining a range where the lower bound is 0, the upper bound is 10, and it's inclusive. So it's actually going to print out the numbers 0 through 10 if I run this. And I'll run that there, and we'll see we had 0 all the way up through 10 itself. So it's not stopping. A question or anything? Or oh, okay. If I wanted it to be exclusive, I would say until. Oops. Something like that. And notice the little hints that IntelliJ gives. It gives the 0 is less than or equal to until less than 10. So it's not going to include 10. So this one I should just see 0 through 9 printed out. There we go. So we got 0 through 10, 0 through 9. And that can be helpful. Sometimes you need one, sometimes you need the other. Until can be really, really useful to give you that first item up through the number of elements. Okay, so let's do a couple others in here. Let's say that we're going to walk through these, but we want to count by 2. I can say step 2, and this will add 2 each time. So in this case, I should see 0, 2, 4, 6, 8, 10. If I did this with an until, I'll just see the 0, 2, 4, 6, 8, because 10 doesn't count in that case. Going backwards, instead of until, I can say down 2. And as far as I know, there's not an equivalent that we can specify to exclude the upper bound, which is a little unfortunate here. Down 2 will let us count in reverse. Well, I really want to make sure that these are reversed, don't I? But it's inclusive on both ends. So if you really don't want to be inclusive here, you're going to have to specify the number minus 1. And you can also put the step on there if you'd like to. So when we run these, we'll see that we got the 0, 2, 4, 6, 8, 10. That's the one that was inclusive. And then 0, 2, 4, 6, 8. That was the exclusive one using until. And then the 8, 6, 4, 2, 0. I'm sorry, 10, 8, 6, 4, 2, 0. The 10 here is from this last one. I really should put the breaks in here so that it's a little more obvious. There we go. So this one was the 0, 2, 4, 6, 8. And then this one starts at 10 and goes down to 0. Okay, and it's not something that I've had to use very often, but every once in a while it comes in handy. When we start talking about functional programming later and how we can actually use functions to do our walks and our loops, you're going to use the direct for statement quite a bit less. Okay, any questions on those? Okay, so those always work on ranges. Or if you just say something in something that's iterable, you can walk through it. And we'll talk about what iterable means later as well. Okay, let's talk about the while loop. So if I said var n equals 0, and then I can say while n is less than 10, println n plus plus. Okay, this one, once again, is going to stop at 9. So I should see 0 through 9 printed out. So this would be the same as this guy right here. But this is a much shorter syntax for it. Sometimes you need to have a little bit more control over that expression, though. So that's a typical while loop. And it looks very, very similar to what you'd see in Java. We can also do something similar. I'll just reset my n and say do. We'll print these guys out while n is less than 10. What do you think is going to be printed out in this particular case? Note that the check is at the end of the loop. Will this print the 10 or will it not print the 10? In this case, it won't print the 10. Let's go ahead and run it just to make sure that I'm not lying to you. We'll see the 9 is coming up there. What's happening here is even though we're checking at the end of the loop, we've moved to 10 just before the check happens. If instead I did something like this, then we're actually going to see that 10 printed. And it's going to print from 0 to 10 because I started before the 0. I increment it before I'm actually printing, and then I test at the end after I've printed. So this time I should see 0 through 10 as my last one there. Let's go ahead and run that. And this is one of those ones that you don't see people using do while in pretty much any language that often. If you do see it, think about it really carefully because it probably means they had a really good reason for executing at least once. With the while loop at the top here, it's possible to completely not execute the loop at all. With a do while, it's always going to execute that first time no matter what. That's the big difference between the two. And you don't see it done very often, but there are cases when people are like, I really need it to always execute at least on the first one. And that's why you'd use him. Let's get a little more complex here. Let's say that we're walking through some things and we want to either skip certain chunks or we want to move to the next iteration. So let's do something simple like I'm going to come up with a while loop here. And let's say that while we're performing this loop, maybe instead of having the condition here, we just check inside the loop itself and say, if I see a certain value, just get out. Oh, my screen just went blank. There, came back. So let's say that we start our n at 0 again there. And I'm going to change this to get rid of that condition. And I'm going to say if n is less than n equals 10, then break. And he's insisting that I have that condition, isn't he? Yeah. So I'll do that. So doing something like this, you can see how often I use this type of format. I couldn't remember that I absolutely had to have that in there. So in this type of a format, somewhere inside the loop, I'm checking a condition and I'm saying, I want to get out if I see a certain value. This gives you the capability to actually do something all the time until the value is met. If the value isn't met, do some other things and then continue. So it's kind of like a combination of the while and the do while. Let's go ahead and try running this. And here we should see 0 through 9 come up with the word before each of them. Well, with that extra before, because you'll notice that it actually did execute for that 10th iteration and is doing the stuff before the check. Sometimes this type of format is actually much more readable. There's some people who are really, really opposed to using break because they feel that everything should have a very well-defined entry and a single exit. And I'm not a fan of the single exit concept. If you do things strategically, sometimes the condition in here could be very complex. You might have to say, while some variable is true and another variable is false and another expression is true or something, continue the loop. Whereas you could just inside the loop say, hey, if I see a condition I don't like, get out. Now this one completely stops the iteration, but maybe what we want to do instead is just skip to the next iteration. So in a case like this, we might want to say if n equals 3, maybe I don't want to do anything. I can say continue. And what this says is at this point in the code, if this condition's true, I want to just go ahead and immediately start the next iteration. I don't want to do anything that follows after. So in this particular case, I should see 3 get skipped, but it'll still keep going up to print out the 9. Let me pull this guy down here, and we'll run that. Well, I definitely did something bad there, because I'm obviously in an infinite loop here, right? Oh, hey, thank you. Yeah, I never incremented this. I did do something bad. There we go. So we'll do that. And let's go ahead and run that. And now we're good. Okay, thank you. And we'll see here that it actually did skip the 3. Okay. And this is something that sometimes, if it's not that obvious to catch, sometimes the debugger is really helpful. Okay. Now, sometimes you're going to have nested loops. And let's say that we were doing something kind of like, for I in 0 until 10, and then for j in 0 until 10. And maybe consistent on my style there. So this is going to have a nested loop here, and we could print out $I, $j, just to kind of print out some coordinates or something like that. But let's say that there's certain cases that we want to actually skip over. Maybe when I is 4, we want to completely skip the loop. So I could say, well, let's actually say something like, let's skip the diagonals. Let's skip it when the values are the same. So I'll say if I is j, if they have the same value, then I'm going to continue. And in this particular case, I'm continuing at this loop. So the continue without any type of qualification is continuing the closest value there. And so we'll continue through there. But let's say that I want to say, if we hit 5, 5, I want to completely skip the rest of that row. So if I equals 5 and j equals 5, this is very contrived, but it gets the point across. So if we hit, now notice how that's never going to be the case. See, Kotlin has actually caught me on that, saying, hey, you already covered that. Let's say that if it's 5, 6, we want to completely skip the rest of that row. So what I really want to do is do a continue up to this guy. Now to do that, what I'm going to need to do is put a label on that statement and then explicitly say I want to continue there. So I can say here, maybe this is rows. Oops, rows at. There we go. And then down here I can say continue at rows. And this is going to say, go to this guy and start the next iteration of him. And we can do the same kind of thing with breaks. But if we run this, what we should do is we should see all of the ones where I and j are the same get skipped. And then anything on row 5 will get skipped at starting at item 6 inside that row. So if we run this, let's go ahead and bring him down. So we're going to see if we kind of look in here kind of briefly. We don't see a 3-3. That's good. We don't see a 4-4. When we get to 5-5, we don't see it. But then when it gets to 5-6, we're skipping all the other 5s at that point. We're just continuing back up there. Now, a similar way of doing this, instead of continue at rows, we could break this inner loop here. So if we had calls there, or break at calls, should do the same thing. Let's actually just try that to make sure. If we come up to those 5s again, we'll see 5-5 is skipped, and then 5-6 and everything else is skipped there. This would actually be exactly the same as just break. Now, I recommend that if you're going to have nested loops and do breaks and continues, always be explicit. Don't use the implicit break the nested one or break the closest one. The column labels or the for labels are a little bit more explicit. In general, you're not going to have to do this very often, but it's a useful technique to know because once in a while you're going to have that, and it really makes your loops a little simpler. If we didn't use continue or break, we'd have to use a while loop with some kind of a more complex expression. So basically the while loop up here would have to know about the, well, actually it's this one. This while loop here would have to do the check for I and j. And so that could be much more complex to try to reason through. Now, some companies may forbid you from using breaks and continues, but I find them useful once in a while. And once in a while might be, I don't know, once every year or two. It's pretty rare that I've had to use them. In the past, I had to use them more, but the different types of constructs we have nowadays make things a little bit easier to do it. Okay, any questions on any of that? So those are all our basic control structures. Let's start talking. Oh, go ahead. Uh-huh. It depends. So the way I've written it right now, obviously not, but if I had start a coroutine at this point that modifies n, then we are definitely in trouble. Yeah, we will. Well, we'll go into that a little bit later in the course. And there's some times where you may intentionally want to do that, but yeah, you want to be really careful. In a case like this, a safer way to handle this would be instead of having n be a variable that can be changed here and inside of a nested function or a nested coroutine here, or nested lambda or anything like that. In a case like that, you want to be really more explicit about making this something that's part of another control structure, like part of a for loop itself. You know, how like here we have inside here for I in this. In a case like this, because we're defining I being controlled by that for loop, you can't have something else modify it. Cool, cool. Okay, so let's go on to, we'll close him out. There we go. Go on to our next section here. Let's start talking about functions a little bit. So we've already had one function that just acts as our main entry point into our application. Let's go ahead and add some new functions here. I'm just going to call function A, and you define these just by saying fun. I did have somebody at one point saying, oh, fun is short for function. I thought it was just because this is fun to do, but it's actually short for function. Now inside of here, you're always going to have a parenthesized list of parameters, but you don't have to have any parameters inside there, but you do need the parens. So what I'm going to do to start with here is define a function that returns an integer. So function A takes no parameters and returns an integer. So inside here, I can just say return 10. Boom. And now we can use this. So we can call it by saying a paren, and then use that value. Or if we want, we could go ahead and call it directly as an argument to our println there. So if we run this, I should see 10 printed twice. Oh, let's run the right one. There we go. Got 10 printed twice. And this is a simple function that has no parameters. And a return value. Now, there's only going to be a single return value returned from any function in Kotlin. There are some tricks we can use a little later to make it look like more than one value is being returned. But essentially what we're doing is wrapping up multiple values into an object, returning that, and then we can use something special called a destructuring declaration to make it look like we're assigning two variables at once. We'll get into that much later when we start talking about object-oriented programming. So very simple function with no parameters. I actually put this comment up here like that. So this particular function, you'll notice that all it's doing is one thing. It's just returning a 10. And because of that, we can actually take advantage of a shorthand syntax that returns a single expression. So we can say fun b equals 10. And that's some really short syntax there. In this particular case, well, we first of all could say explicitly that it returns an int, but we don't have to, because in this particular case, let's say b1 and b2, Kotlin can infer the type of that value. So in this case, we're being very explicit that returning an int, but in this case, it's implicitly returning an int. And we'll see down here, if you look at where it says, whoops, let's see if I can get that, there we go. If you look down in here, it says public fun b2 returns an int, even though I didn't say it. It's inferring that type. So those ones I can call, so b1 and b2, and there we go. We start getting 10s all across the board. So nice and simple. Returning values, pretty simple thing. The expression can be more complex than that. So if we had something like, let's say var n equals 20, we could have something like fun c equals if n is less than 10, then 10 else 20. Let's do something kind of like that. And this is something that you're going to see from time to time. When you have a fairly simple expression, sometimes it's perfectly acceptable to omit those curly braces. Most of the time I prefer the curly braces, but if basically what you're doing is a ternary expression from Java, this is how you do it in Kotlin. There's no equivalent to the ternary. So this is equivalent to n is less than 10, question mark 10, colon 20. So if you've ever used those ternary expressions with the question mark colon like this is how you do it in Kotlin. You don't have a choice. You are perfectly allowed to break this up. Something like that. And if you'd prefer, go ahead and put those curly braces. Kind of like that. This is still a single expression function. But now we're doing something more complex by using if as an expression. And we can do the same type of thing with the when. I'm not going to go through the example there, but you could see how we could build on it that way. And this can be a lot more terse. You notice how we don't have the word return in here at all. We're just using the actual value of this if expression, versus up here, if we put a colon int, if we did this as with an if as a statement, we'd have to have the return. But watch what happens. Notice how this if up here gets squiggly? It's saying you can lift the return out of there. So another alternative to this one is C4. I'm going to hit Alt-Enter on when I have this squiggle, the cursor's in the squiggle, lift the return out of the if, and we get something like that, which we could also do in the ternary format like we had before to be more concise. That'll be C5. So all of those are doing exactly the same thing. I ended up, for this particular function, I would choose this format here because it's a short enough expression that I think it's very readable at that point. If the expression were more complex or the values inside here more complex, then I would choose a format more like this. But I do like to have the single expression functions. If the return type here isn't obvious, in this case, looking at this expression, it's super obvious the return type is integer. If it's not obvious, specifying it up here explicitly is going to help your readers. And that's especially going to be true when you have things that are nullable. And later on, we'll see we put a question mark, which means you can assign it to null as well. So in a case like that, if the type is going to be helpful for somebody reading this, put it in. If it's really obvious, don't worry about it. Any questions on that? Okay. So another thing that I like to do in functions is take advantage of fast fail. To do this, actually, I want to talk about parameters before I do that. I'll just put a little comment here, fast fail, just so I don't forget to do that. Let's talk about parameters. So being able to pass some data to a function is super, super useful. I'm going to pass in an x and a y. And I'm going to say equals x plus y. So here again is a single expression function. I could also get rid of the return type on there because it's going to be pretty obvious. And this ends up looking a lot more like math. I mean, it's a nice compact syntax. So it kind of looks like d of x comma y equals x plus y, which is a much more mathy way of doing this. The difference is that we put these explicit types in here. There's no way to reduce the types in the parameter definition because you're telling the compiler. The compiler doesn't have any information to be able to figure out what those types should be. So let's see, in math, just do something kind of like that. So if we call this one, what is it, d with two parameters, d of 1 comma 2, I should get a 3. Let's go ahead and print that. And there we go. We get our 3 printed out. These are really, really simple parameters. And if you have a few of them, putting them on one line isn't so bad. But refactor that to D1. Make this be a D2. There we go. What I just did there, by the way, is I hit Alt-Shift-R. Or if you right-click on him and say refactor, rename, then it'll give you some suggestions, but you can type in anything you want. And as you type that, you'll see up here, it actually changes the call site to keep those guys in sync. I'm just going to undo that. So if the parameters aren't going to fit as well, then what you'll typically see people write is something kind of like this. And you could still use the single expression function, or you could actually convert it into a normal function body there. Now, one little gotcha here is that as people add code, like let's say that I wanted to add a z, I could come in here and say z:int. But notice to do that, I had to change 2 lines. I had to add that comma, and I had to add the z:'int. And this is something that if you're doing a code review, you're going to see 2 lines change instead of just 1. And so, it's not a huge deal, but sometimes people will take a look at code changes and just count the number of lines that have changed. And if you're using some review tools, sometimes the review tools will show that information, which kind of gives you an idea of, oh, this is a much more complex change than it needs to be. To get around that, it's perfectly valid to have a comma after the last item. And usually syntax-wise, you don't do that when you actually have the parameters in the same line. But in this case, multi-line parameters always add comma after last. And this is a style thing. Again, it may depend on the style guide at your company. The general advice here is if you have multiple lines, put the comma after the last one. And when you do that, it's just easier for somebody to add in a new parameter later on. And Kotlin will ignore it. It's perfectly legit to have that. And I'm glad they added that in because it's just so much simpler than a lot of languages, especially like things like JSON when you're creating a list of things. And if you copy something in, it has a comma on the end, then you get an error, which you might not notice until you run the application. So those are very simple parameters there, just some basic stuff. And when we call these functions, you notice how we called it with D1, we can call it with D2, same way. Both will work just fine there, getting our 3's back from there. But we can also be a little more interesting on this. Notice how both those parameters are integers. And let's say that we had a bigger list of parameters. I'll go with E1 here. Let's actually make these be A, B is list, person exists, and maybe Z one of the problems as your lists grow, in this case I'm just going to always say return A plus B, I'm going to ignore the other parameters. Note that the parameters that are ignored are showing up in gray because it's saying it's not used. So good thing to check there. But let's say that we define something like this, where we have a couple integers, a couple booleans, and another integer. So let's come up here, and we're going to print E1, a couple integers, true, false, and 10, something like that. Now inside IntelliJ itself, you'll notice how it puts these little hints to tell you which parameter is which. But if you're printing the code or if you're looking at the code in some other environment, just a text editor or something, all you're going to see is 1, 2, true, false, 10. And you're going to have to go and look to see, oh, which one is which there. And if somebody reorders these, you might have some trouble there. Like if A and B get swapped for some reason, you're going to have different values. So instead, what we can do is actually name the parameters when we do our call. So if we go with E1, and I'm just going to kind of break this down a little bit here, we can explicitly put A equals, B equals, is list. Well, actually, I can just Alt Enter on them. There, add names to this and all following. There we go. Those little quick assists actually help quite a bit. So we can end up with something that looks kind of like this for our call. We're explicitly naming the parameters. And this sets it up so that even if somebody down below swaps the order of A and B, Now we'll notice up here, this guy says B is 1 and A is 2 because it's been swapped. But here, even though those were swapped, we're guarded against that because we're explicitly saying which one is which. It also has the effect of if you take a look at this in a printed form, or if you take a look at it in a different editor that doesn't have the little hints that IntelliJ does, you'll know which ones are which here. That makes things a little bit more obvious. We'll see up here that he's actually saying Boolean literal argument without a parameter name. That little lint check is basically telling you, hey, you've got multiple Booleans in here. It might be confusing to somebody what this true means, and what this false means. So by using named parameters, you can get around that. And that's actually pretty nice. And it gives you that safety for the future. Depending on what the function is you're calling, some functions, the order will be obvious enough. So if you're calling a function that's maybe a graphics function dealing with a point, it might be perfectly obvious that X and Y are parameters in that order. If it's not obvious, naming the parameters is a really good idea. Okay. Now, the next step on this is, what if I don't want to specify all those parameters? What if there's a reasonable default for these things? Let's bring up a F1 here. Let's say that isList is perfectly reasonable to say no. By default, it's not going to be true. And personExists is going to be by default true. And maybe Z by default is going to be 10. You can add in code that looks like this, and now the caller doesn't have to specify these. So if I come up here and I call F, I can pass in all the parameters if I want to, or I can skip some. Maybe I skip personExists. Maybe I skip all of those optional parameters because they have defaults. This gives you some flexibility and sets it up so that if there's a reasonable default, people can use it. This is much nicer than what you get in Java, because in Java, you would have to define multiple functions. F1 taking the A isList, personExists, Z, that guy, and that guy. So Java would have to define something that kind of looks like this. And then we'll pass it in the 10. And then do the same thing down here. Passing in the 10. And what did I say? personExists is true. And then this guy, true and false. So in Java, you'd have to define, and I'm not actually using the real Java syntax on these, but you'll get the idea here. You'd have to have one function that has all the parameters, one that has all except the last one, and then calls the first one that has everything except the last two, and one that has everything except the last three, and you call them with those default values. So that's basically the equivalent you have there. And that can be pretty verbose. Kotlin will let you also, so we had isList, personExists, and Z. So in this case, you'll notice that I removed a parameter that was in the middle, this personExists. You couldn't do that in Java at all. Well, you could if you defined specific overrides for things, because you'd have to have like different permutations of parameters to make that work. But it's nice and easy inside Kotlin. We'll take a break in 1 second here. What I also want to mention is, in order for compatibility to work between Java and Kotlin, you can actually have Kotlin generate all of these functions for you automatically. So if I had this guy and put in at JVM overloads, this is a special annotation that tells the compiler when I generate code for the Java virtual machine, and only for the Java virtual machine, I want to generate these functions. So one that has all the arguments, and then dropping each individual argument so that it's basically the equivalent Java code. And in Java, obviously, we call them methods instead of functions, but I kind of wish they would have called them functions. It would have been simpler. Keep in mind there's this word overload versus override. Override is an object-oriented term, and that's talking about if you have a subclass, one of his functions is replacing the function in the superclass. Overload means you're using the same name, but you have a different argument list. Something like that. Any questions? You can actually have them anywhere you want. And then so the first one here, you could do something kind of like that. I think. Let me just double check that I'm saying the right thing. Because I know it at least it used to say that you couldn't do this because once you have a default parameter, everything after it has to be default. I don't think that's the case anymore. It may be the case if you're using JVM overloads, because that would make sense to me that you could, once you have a default, everything else has to be default. Let's just see what happens when I try running that. Okay, that ran just fine. If I run it from Java, I wouldn't be able to take advantage of, I would always have to define A. I'm not quite sure how this would, it should still produce these same guys. Well, it'll be interesting. I'm going to have to take a look and see what it will generate for the JVM overloads here with this as a default value. That's interesting. I hadn't really thought about that here. Yeah, that's interesting. I'll have to take a look and see, because that used to be an error several years back, and at some point it stopped being an error because I had done code like this and it worked just fine. Yeah, I'll have to try that and then decompile the Java code and see what actually got generated. My gut is telling me that it actually treats it as though the A were the first parameter, but I'm not sure. Well, no, it should be able to generate that code because it's just going to have different versions whether B is there or not. So that might end up doing, not that guy. It might end up generating this, but I'll have to take a look. That seems reasonable that it could generate that code, but I got to see if it actually does. That might be something that they've done because that would be nice. I mean, that's how I'd write the code, manually in Java, which is gross because you have all those overloads. But I think that would be what it'd be generated. I'm going to have to take a look at that after the class. Okay, any other questions? Okay, let's take a 10-minute break and we'll start back up at 8:45. Okay, and we're back. So I wrote up a quick little a piece of Java code here that calls some of our functions. Notice that I have source main Java as the directory. You have to put it under source main Java. Java can only live there. I'm sorry, no, other way around. Kotlin has to be under the Kotlin, but Java could be in either one of them. So I could have actually made this in the Kotlin directory as well. So what I did in this code is I wrote a little class to hold on to a main function, which is what you need to do in Java. And let me just make sure I got everything started here for recording. Yes. And created a main function inside there. And I'm calling main KT, which is the week 0203 version of it, the function defined inside there. And what I did just to check on this is I hit control space after the F, and here's the functions that got generated. Now the ones that are after A seem pretty reasonable. We had, B through Z, B through person exists, B through is list, B and then A. But look at A here. With the way that we defined it as optional, it defines only an int A function and doesn't have A to any of the other ones. It just has the defaults. That doesn't look very helpful to me. So it's safest to use the optional parameters. Everything else after it should be optional. Safest option once you have a default value. Well, I'll say have an optional parameter. Only have optionals after it. So this will work inside Kotlin, but better to have the code look something like that. Okay, any question on that? And I could see there'd be cases, depending on what your parameters are, if they tried to do what I did down here. Let me get rid of these guys. Wait a minute, which one do I want to get rid of? Oh, I swapped these around. And then not, whoops. Let's see, person exists. Wait a second, did I do this right? So that guy calls him. Just make sure I got these in here right if you look at it later. And then if it's just A, calls A with 10. There we go. So that's going to be your safest construct, is to do it like that. And one of the reasons that it does some interesting things like what it just did is it could be ambiguous in some cases if you have kind of a mix. If you had like a couple ints and then a couple booleans and a couple more ints, and there was a mix of optionals in there, it could be ambiguous which one is the optional if they didn't restrict it like this. Okay, so that's that guy there. Now, let's get a little more interesting here. We're going to say fun G1. And let's say that we want to define a function that can take any number of arguments. It's up to the caller to define those. That's where we're going to specify var arg in front of something. And we can say var arg and the name of the variable. Let's say items. And then maybe a type after that. And then inside here, let's actually create a string of just concatenating all this stuff. So what this creates on the inside of the function, items, is going to look like an array. Now at this point it says it's defined as a var arg, but you use it as an array because it creates an array for you. So I could say for item in items, and then let's define a string here. Then we can say result plus equals. I'll do it this way. We'll say item plus comma. Ooh, what am I doing? $item. And then the comma, something kind of like that. So this will leave a trailing comma on the end, but not that big a deal. And then I can say return result. So this will concatenate them all together. There's much better ways to concatenate that we'll see later. Let's do a println G1 with just A, and then we can add in a B, and we can add in a C, and maybe, oops, and maybe a D, E, and an F, something like that. So you have any number of items you want, and that creates an array that you can then walk through. So for those guys, when we run that, we'll see the A by itself, A, B, then A, B, C, D, E, F, something like that. Now, you can do something similar in Java. The problem is when you do it in Java and then use that array, if you want to pass that array as a value of those just separate items to another var arg thing, it's very difficult to do. You could end up with ambiguity. Usually, what ends up happening, if you had like a function that took a list of objects, when you pass the array in, it'll assign the array as the first object instead of having each of the values. With Kotlin, it's really explicit. So if I created another function here, let's call it G2, takes my items, and let's say that I wanted to turn around and call G1. If I wanted to say return G1 passing in items, that won't work. That's a type mismatch. When I'm calling G1, every one of the parameters has to be a string in this case. And if I float over this, it's going to say, hey, you're passing in an array. I don't want you to do that. So instead, what you do is you use an explicit operator to say how to do that conversion. And that is just putting a star in front of that. And that works. It spreads the arguments out. That's called the spread operator, surprisingly enough. So what it does is it takes each of those arguments and makes them a single argument in the call to G1. So you're breaking it back down. There are going to be times you're going to need to use this when you have one function calling other functions. If we did something like fun G1a, x is a string, y is a string, z is a string, something like that. And tried to call it here instead. Oops. Let's do actually, I don't want to have a return type on this guy. If we try to do this, it won't work. So we float over this, he's going to say no value passed for y, no value passed for z. It doesn't know how to say just pick these three items out of the list and then match them up. So if you wanted to do something like this, you have to be really explicit about it. And you can. That's the nice thing about this is you can be very explicit. You can say G1a passing in items 0, items 1, and items 2, because you know how many arguments you're expecting. And that will work. Up here, you don't know the number of items needed. Now note that in this particular case, if you have more than 3 items in that var arg list, it's going to ignore them. It's only going to pick the first 3, and anything else is just going to be completely ignored. There may be cases when that works out just great for you. There may be other cases where you're like, oh, wait a minute, that's not what I want it to do. And in that case, you may have to have some fun breaking the list up into sublists of 3 items and then doing this type of call multiple times to handle them. Maybe you're handling them in chunks of 3 down the line. The spread operator, you're not going to need to use it too often, but it's just generally if you have an array of things and you need to split it out into var args, that's where this would work. Now var args also work if you have other arguments. So if I had x as an int, y is an int, and then var arg items string. And you're going to see some different styles, by the way, on the naming of this. I like to name it with a plural name just because when I'm using it, I think it makes more sense. You'll also see other styles where people just say var arg item. And that just doesn't smell right to me, but this is a pretty common way of doing it. So you may see that. I'd recommend you go ahead and pluralize that just so it's a little bit more obvious that it's an array that you're working with. So in a case like this, we have our var arg of items after X and Y. So it'd be on the end there. You'd need to do this for Java compatibility. In Kotlin, you can have it earlier if you have, I believe if you have default arguments or named, I think you'd have to use named arguments for it to work. So if you did something kind of like this, where let's move the var arg up front. I'm pretty sure I've done this before. Don't really recommend it because it's not going to be compatible with Java. G4A, G4B. So this particular one here, we'd have to name X and Y so it knows where to stop, especially if they're strings. Let's make them strings like that. So in a case like this, if I had like G4B, G4B, and we're going to pass in a list of items, A, B, C. I think the trick is we have to actually explicitly name them. Or can we do it as this? Let's see if this will work. No, because it's going to say nothing's passed for X and Y. But if I name them, that works just fine. I don't recommend you do this. There are a few cases where sometimes this seems a little bit more readable. I'd recommend you try to set it up so the var args are always the last one. So we recommend that we always put var args last, especially for Java compatibility. Which in Java, that's the only way you can use var args is make it be the last argument in a function. Okay, any questions on that? Not something you use a whole lot, but go ahead. Go ahead. No, there's no way to actually do that. As far as I know, there's no way to do it. If you do need to name it, or if you want to have multiple var arg groups, then you'd actually have to explicitly say, I've got a list here and a list here. So something kind of like, if need multiple var arg groups must use data structures like list or array. So in this case, you'd have to actually say fun G4C. He would have something kind of like a, let's say names. Ooh, what did I do? Would be a list of string. And then addresses, list of string. Not that I'd write a function like this, but this is one thing you could do. And then in this case, the call to it would look more like G4C list of Scott, Mike, Steve, and then addresses is list of 123 Sesame 456 Blunt Street and 789 what's it? Something kind of like that. So that's what you'd have to do, something more like that if you had multiple groups. I would prefer in a case like this, because these are probably intended to be paired together, pass in either a map or pass in some other data structure that groups things together. So it might be a list of person objects, for example. Okay, that answer your question okay? Cool, cool. Okay, any other questions? Yeah, it could be used on an array if you have an array passed explicitly in. So if I had a fun G4D, and let's say that it passed in, I'll say names again, which is an array, of strings. And if I wanted to pass that into G3, for example, which is taking that var arg, then I could say G3 spread out names, and then we're in good shape like that. So you can do that with any array. I can't remember if we can do that with a list. Let me see here. I don't think so. Yeah, it won't work with a list. It'll only work with an array. Yeah, you can spread out. Our params. So you can take any array and spread it out. And sometimes you'll see, this type of a conversion happening where you might have an array that exists, and then there happens to be a var arg function that you want to call, and this will work just fine. Mm-hmm. Oh, you mean having like an equals here? So let's think about what this is doing here. We're doing a single expression, and actually, let me make a copy of this one here, because this is something else I needed to talk about. So nice segue. What is the type of G4E? Because when you have an expression, you're returning something basically, right? We're saying G4E is going to return the result of G3. But if we look at G3, he doesn't return anything. So that's kind of a big question here. And the way they work this in Kotlin is there actually is a return type for all functions. And the return type has a default to it. Default return type in Kotlin is unit. And unit is a special object that just represents I'm not returning anything. And so the compiler can treat it a little bit differently, saying, oh, you're not returning anything, I don't have to assign a value. So in a case like the above, the compiler sees this and says, I'm not returning anything, therefore this guy isn't returning anything, and the equals is really just calling this function. He's not trying to get a result coming back. So this actually looks like, let's see, I'll call it sample function. Something like this. You can explicitly set unit as the return type, but it's never needed, and you'll probably never see it. So this, when we have sample function, I'll call it sample function 1, it's exactly equivalent to sample function 1. Something like that. So all unit means is you're not returning a value. And this is going to be super important when we start talking about functional types in a moment here, where when we're defining the type of a function, we always have to specify the return type. So in that functional type that we're going to define, we're going to need to use the word unit quite a bit. Okay, so let's see, which one do I want to go into next here? I'm going to hold off on recursion talk for a little bit here. Just move him a little later in my list here, because I actually want to jump into functional types. So let's see. Let's go to, that was 203. Let's go to 204. Let's talk about a few concepts first here. What I'd like to talk about is something called the template method and strategy patterns. Boy, you'd think I could spell these by now. When we're dealing with design patterns, we're basically going to have two concepts for two different patterns that play really well together, and that's template method and strategy. And the template method pattern is basically an algorithm with replaceable steps. Think about how many times you've written functions where you're doing the exact same thing, but then maybe one little part changes. So maybe if we had something like a, let's say, print numbers, and we'll say var arg nums, and then in there we can actually do a little for loop here, and we'll say for num in nums println num. So this is like one option here. Maybe we're going to print the numbers, but maybe also we're going to print average of numbers. So in a case like this, the function is going to be a little bit different. Well, this is I don't know if I want to use this. Let me tweak this a little bit. I don't want to use that because that's going to be a little more complex than I want here. Let's have it be names. So we'll print names. And then we'll print doctors. Let's just promote everybody to be a doctor. And let's say we're going to print here doctor $name. So these are two functions that there's a lot in common on this. We're taking in the same type of arguments. We're walking through this this list of names, but we're doing something slightly different. In one case, we're printing the name itself. The other case, we're modifying that name before we print it. And in a case like this, we basically are performing a lot of redundant operation here. And this is a fairly simple example of it. Most of the time, you'll use this when you have a more complex function here that's going to do things. I'm going to break it up kind of like this so I can say those parts are redundant as well. So we'll notice how we have what's being printed is changing. Let's see. Different. I'll put this down here. So the actual argument that we're passing to println is different, but the general algorithm here is exactly the same. We're just tweaking a little part of it here. Whenever you have a case like this, it can be really useful to make a template method. So a method that has all of the redundant parts just being exactly the same all the time, but then the different part gets computed separately, and that gets passed in as an argument to the function. And in that case, we would call that a strategy that we're passing in to perform the what are we printing. The walk through the names and the fact that we're printing them stays the same all the time, but the actual what we're printing changes from time to time. So the goal here is to create a function that can keep all the commonality and take another function to decide what to print. And this is something that becomes very, very useful when you have some more complex data structures. Like if you think about, you have some kind of a tree of data, and the walking of the tree, that mechanism is always going to be the same. The what to do at each nodes while you're walking may be different. And so that way you can keep all of the walking code isolated. That also helps you make sure that the walking of it can be hidden along with the tree implementation details, just exposing the fact that there is a function you can call to walk the tree, and then somebody else passes in well, what do I want to do at each node here? To do that, we need functional types to define the parameter. So if we take a look at this fun print stuff, I'll call it, And we're going to take our var arg names string, and we're going to have this other code that's inside of here. And inside here, we're just going to have something like a get thing to print, passing in the name. So we basically want to call another function to do things, but we want that function to be able to be passed into print stuff so that we can actually reuse this common algorithm, print stuff, over and over and over again. So we're going to pass that in, get thing to print, as a function, and this is a strategy. This is a template method. Now in Kotlin, we don't use the word method to refer to our functions. Even if they're inside of an object, we always just call them functions. But the term template method is from the Gang of Four design pattern book. And that book, if you haven't read it, it's a real sleeper. If you want a good night rest, if you're having trouble falling asleep, read the design pattern book. It's got great reference material inside of it and some great concepts. But I remember when I was first reading about what the visitor pattern is, it's that one in particular is really tough to get through and get the concepts. Maybe later in the class I'll go over or point you to a talk that I did about it. Depending on how you walk into learning about the visitor pattern, boy, that's a great pun. Didn't mean that. Depending on the path you take to learning about it, it can be kind of a no-brainer. But if you try to just look at what they've written about the visitor pattern, my head hit that book so many times. Just I'd fall asleep and my head would hit the table, and then I'd wake up and I'd be like, "Where was I?" It was nuts. But I mean, it's a good reference document. It can be really hard to get through. So what we want to do is put some kind of a functional type here to describe what kind of function gets passed in. We do that by specifying parameters in parentheses, arrow, and then a return type. So in this case, a string. So we're going to take a string is what we want to do. So we're going to pass a string in. That's what we're going to do here. And we're going to return a string. So this is going to be some function passed in that tells us what to do at each place. Print stuff can then be a nice generic, and it's a bad word to use here. Let me say a nice I'll just use the word template. It can be a nice template for how to do the walking and when to call the strategy. We can then call this something like this. So we can say print stuff. Let's create a function that we can call inside there. So we got two possibilities: just printing the name itself, or printing the word doctor in front of it. So I'm going to say fun, just print name. And fun, print doctor name. Something kind of like that. So I defined a couple functions here. And if we think about composing functions in math, boy, I'm having a really bad typing night today. I don't know what's with my fingers. We can compose functions. So you can write things like f of g of 10, something kind of like that. And what we're doing here is calling a function and then calling another function on it. Or we can do something kind of like f of n equals g of n with some kind of a function around it, like let's say f prime g of n. So we're going to call it, and behind the scenes, f is going to do some work for us. Or we can say f of n comma g equals g of n. And so what this is going to do is it's going to take a function. You're going to run that function to be the result of f. So there's a bunch of ways we can compose functions in math. We're basically doing that here, but we don't really have to think mathy on it. We can think more about functions themselves. And what we do in functional programming is we call these higher order functions. And there's really two types of two types of things you can do to make something a higher order functions. One, pass parameters, pass functions as parameters, and or to return function as result. So you can have a function that creates another function, or you can have a function that takes functions to help you out. And the easiest way to think about them is this template method idea. If you think about, I have a structure that I'm going to run, and at certain places I want to replace functionality, where each of those places to replace the functionality is a function I pass in, things get a little bit more clear. Thinking just pure in math about what you're doing with things, and it's been a while since I've done any of this in math, so this might be incorrect. If any of you are math types, please don't kill me over things like that, but there's some things like that you can do in math. Here, what I want to do is I want to call print stuff. And what I'm going to do in the print stuff here is I'm going to set up my list of items. So list of names, let's say Scott, Mary, Steve, and Sue, something like that. So I have those 4 names, but I also need to pass in that function. And this is actually one of those places where it's a good thing to have the var arg list come first. I'm going to go ahead and name the function, but there's a nice little trick I can do that makes this even cleaner because I have that functional parameter as the last parameter in the function. So I can inside here say get thing to print and reference one of these functions. Now to reference that function, I say : just print name. Or I could come in here and say : print doctor name, something like that. So what I'm doing is I'm taking this function here, which has the same signature I need. Notice that the parameter type is just string, so there's just a single string being passed. That's this guy. And the result being inferred from the expression over here is a string. So this guy matches this type declaration, and this guy matches the type declaration. So doing that, I can just go ahead and pass these functions in and say, here's the data I want to work in. Here's how I want to replace that get thing to print. And when I run this, I'll see, first of all, the names printed just as is, and then the names printed as doctor names. Poof, ta-da. We've now created a higher order function. Print stuff is a higher order function that takes another function as an argument. Any questions so far? And if you haven't done this before, it's going to feel a little weird, but it's super, super useful. And it's especially useful when you are working with data structures where you can pass in arguments like this. And if you do things like in an environment like Android using Jetpack Compose, some of you have been in my Android class. If you see that, it's something that is used very, very widely for returning, for passing arguments that will handle events coming back to the callers. And this is nice if you're going to reuse just print name and print doctor name a lot. If you're only ever using them in one spot, it's a little wasteful. So if we're, go ahead. It's a function reference. So when you say : that is a function reference. So what it does is it basically says use that function as though it were a variable, so I can pass the actual what the function does as an argument. Now if we're only ever using the functions just print name and print doctor name once, This is a good bit extra to define. We can shorten this. And the way we shorten this is to define the function inline. So instead of defining a name for this, and then defining the parameters, and then defining the value, we can actually put that in line in the call. So if I come into here, and I want to do the doctor version of this, what I can do is instead of doing :print doctor name, I can say open curly, name, arrow, and I'm going to say name : string, doctor, dollar, name, something kind of like that. And so this type of a syntax here is defining a function in line. Also known as a lambda. So we're defining a lambda here, which is an unnamed function that takes some arguments. Notice how name : string there is exactly the same as what we put in the parens up there. And then an arrow, notice that that arrow matches the arrow up here, right? And then how do we get the result? So it can be a single expression, or it can be inside curly braces if we want to do something more with it. So if we did something like this, let's say, I'm actually going to spread this out a little bit more so it's a little bit more readable. If we wanted to do more with this, we can put multiple lines. So we could do something kind of like val doctor name. Oh, come on, fingers. Equals doctor dollar name. And then we'll return doctor name, something like that. We can have multiple lines, and maybe we want to print out doctor name. I'm just going to say debug : $doctor name. So maybe we were doing a little bit of logging in here so that we could see what's going on. We might put a debug statement in there. So this function here now has multiple steps. And normally what you do is you put, after the curly brace up here, the argument list with the arrow, and then inside you have the function. Note how it has this little caret lambda there. This is saying this is the return value for that lambda that we're creating. So we're doing the same thing here. We're just doing it in more steps, being a little more explicit, as well as adding in this debug. And let's actually see what happens when we run this. So we'll see here that we're getting, on that first run, we're getting the Dr. Scott, Mary, Steve, and Sue. The second run, we're getting the debug statements with the resulting stuff coming out of them. So all a lambda is an unnamed function. And that's really, it's just a nice shorthand so you don't have to define a separate function that you're only going to use in one place. So, we can end up coming in here and doing different things pretty simply. So in order to get the thing to print, we're going to say name is just a person. So they're totally not special. We can do something kind of like that. And we can shorten this up a little bit more. In Kotlin, there's very, very often a shorter way to do everything. Note that we're defining a name here, but what's the type of get thing to print? If I float over that, you'll see the type of get thing to print is I take an argument that's a string and I return a string. Now, because of that, because I've defined that inside print stuff, it can infer the type of the parameters. So I can just get rid of the type name there. So can infer the type names. Boom. And so now we have name, and name is just a person. Now, if we only have a single argument, we can not, we don't have to specify. its name can just call it it. So something like this, we can take this guy and we can get, since there's only a single argument here, we can get rid of that argument completely and just say the word it. And it'll know that it, if I float over it, it knows it's a string because the definition of get thing to print says the only argument coming in is a string. And this trick will only work if you have a single argument. Sometimes it can really shorten up how your code actually looks. If there's any ambiguity, or if you just don't like using it, you don't have to use it. You can explicitly name things every single time if you want to do that. So a case like this, we're explicitly naming it. Now, like I said, there's pretty much always a shorter way in Kotlin. And there's a really nice trick that I like here. And that's if the last argument of your function is a lambda, you don't have to specify its name, and you can move it outside of the parentheses. So I'll write that down here. If last arg is a function, you can move it outside parens. And let's see what that looks like. I'm going to take this exact same call, and I'm going to, I'll just pull these all together like this. Ooh, there's no longer a function reference in there. Let me get those out of there. Okay, that's good. So what I can do here is I've got the parentheses, and I can just put the curly brace right there and right there. Why is that indenting like that? That's weird. Something kind of like that. So this is a little shorthand. Something kind of like that. So you can say print stuff, blah, 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 and then the body of that inside of there. And we could also, if you wanted to, if it's short enough, we can go ahead and put that on the same line. Kind of like that. That's another way to do it. Or also, if we wanted to specify the name instead of using it, we could say name arrow. And you'll most often when there's an argument, you'll see the name arrow and then start a new line for the body down there. Either of those will work. And this is really nice because it compacts things and makes it look more like a declaration of what you want to do. It actually makes print stuff look like a control structure where print stuff is acting using this here. But this is only good if you have a single a lambda. If you have more than one lambda, general advice, specify all inside parens with named arguments. I should say as named arguments. So let's look at an example that maybe we might have multiple lambda arguments being passed in. Let's take our print stuff. Let's make a print stuff 2. And let's say there's a get thing to print, and then we'll say print before and print after. So there'll be stuff we're going to print before and after. So now we have 3 things that we're putting in here. But let's make these optional. So if we want these things to be optional, actually, let me make this a little bit more generic. I'm going to say do before and do after. So if we wanted to print, the printing would be inside there. So as optional values here, I can just say bloop, bloop, just kind of like that. And why is he not happy there? Oh, because I'm not returning a string. These guys actually, because these ones are just performing functions, I'll say unit, which is what I intended. Now we're good there. So this is saying that I need a function that defines a string and doesn't return anything. So it could do something inside the function, might not do anything. By defining curly brace like that, this is the same as name arrow do nothing. Something kind of like that. So quite often, this is actually a really good way to specify a default for a function. And then what we'll just do is before we print it, we're going to say do before, and then do after. And we're going to pass the name in case that's needed from somebody. There we go. And so we could print something before, we could print something after, whatever. So this gives us a function with multiple things to do. If we're calling it and defining do before and do after, then we should put these guys all inside the parens. So we can do something kind of like la 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 la, print stuff too. And let's get rid of that. And so now we'll say thing to print is it, and do before is println. Actually, let's do a print. Let's put some indentation in there. So I'm going to call print instead of println. So this will actually print in some space before it prints the name. Not a great option, just to be honest, because we're making some assumptions about what print stuff 2 is doing. We're assuming he's doing printing followed by a line. And do after, I'm just going to print an extra line after it. So print stuff 2. Let's try running that, see what happens. So see, you have extra lines. We have that indentation beforehand there. So this is what I'd advise if you have multiple lambdas in your call. You can, because, well, let's see, is get thing to print the last ones? I don't think so. I think I made the other ones. Let's move get thing to print to be the last. Now, because these are optional up here, get thing to print being the last one, if I only want to specify it, I can just specify it. So I got to have something kind of like print stuff 2. I'll put the names in like that, and then do it. Something kind of like that. So in this case, I'm using the default of do before and do after. And it really kind of depends on how you're calling it. If you're calling it with more than one lambda, I strongly recommend you do this. It makes it much more readable. Having a combination of a do before and a do after in the parens, and then the get thing to print outside, kind of like this. Can be a little confusing. Every once in a while, you'll see something where a concept is really well defined, like Jetpack Compose inside Android has some APIs where you would normally do it like this, have some lambdas defined in here, and then the one outside always follows a certain pattern. So sometimes you'll see that, and then that's okay. But most of the time, this can be really hard to figure out what's going on because it's not clear which lambda this is, because you're going to have to go and read the code for it. If the only thing that you're specifying is the last one, this isn't so bad. There's not necessarily that confusion there. Okay, any questions so far? Now, if you haven't done lambdas before, this can get a little confusing. And let's take a little look at something else that you can do with lambdas that can be kind of useful. let's say that, let's define here a do stuff function with an x integer and a y integer. And inside here, I'm just going to println something like that, and then a println x equals $x and y equals $y. Print another one of those guys. And let's take an argument in here that's a lambda. So let's have a do something. He's going to take two arguments in this case, x and y. Actually, int and int. And if you want, when you're defining these types, you can put names on them if that seems helpful. And I'm just going to say unit because he's not going to actually return a value. And I'll just say do something. Passing in x and y, something kind of like that. And yeah, I think that's what I want to have it do there. And to make this a little bit more interesting, inside my main, let me say var z equals 0. What's going to happen when I call do stuff, passing in 10, 20, and then inside my curly braces here for the do something, I say println, what is he unhappy about there? Oh, the argument's coming in here. So in this one, it's going to be x comma y. That's what I did. Note that because there's more than one argument, I can't use it. I have to explicitly pass those. So that x and y matches this x and y up here. So let's actually inside here print x plus y plus z. Now this gets interesting. What do we have here? Variables never modified can be declared using val. I'm just trying to decide how I want to talk through this. Let me just move him out here. And let's going to say, first of all, what is happening here with z? So you notice that we're referencing z, which is this variable out there, inside of this lambda. So the lambda has to know something about the environment that contains z. And there's a couple ways that different programming environments deal with this. One, like Java, if you're using Java and you define an anonymous inner class, it's going to do what it calls treating z as effectively final. So in Java, z would be treated as effectively final. And what that means is that it basically says if you use it inside that lambda, you can't modify it after the lambda has been set up. And so really what it ends up doing is it makes a copy of the value of z and won't let you modify z after. So let's take a look at that in some Java code. So if I come up here and let's see, I want to define a little interface here. Oh, I'll call it foo, why not? And we'll define a function inside there. Let's see if I get my Java syntax right here. Let's see, what did I want this one to do? I just wanted to use the value. I'll just have it print out a value. So we're going to define a function that doesn't return anything here. And I'll just call it lowercase foo, why not? And wait a second, what am I trying to do? Oh, I'm trying to define a noun inner class. Okay, sorry, I just blanked on that for a minute. So void foo is going to be a function that's going to be run. And let's define a So we use that for an anonymous inner class. Let's define a function that is going to we'll define a function that's going to pass in an anonymous inner class and a variable. Okay, so we'll say void do something, and we're going to pass in an instance of foo. Oops, you can see I'm getting my syntax wrong already. There we go. I'll just pass in an instance of foo. And then what this function is going to do is just call foo to do something. And, oh, foo.foo. Wow, this is not, let's call that go. And we'll do something kind of similar to what we did before. I'm going to say system.out.println. We'll put out some output around it. So this is, again, a template method. And what this template method in Java is doing for us is it's going to take the strategy because we're running this in Java, the only way you can pass a function in Java is to actually pass an object containing that function. So we're passing an instance of this foo, whatever it is. Foo is some object that has a go function in it. We're passing that in and then calling that go function. So let's see what happens if inside of our main we do something like, what is it doing here? That was weird. It was just forcing me to collapse. If we do something kind of like that, let's define a variable here. So I'll say int x equals 10. And note that I'm not saying x is final. In Java, if I put the word final in front of it, that explicitly means you cannot change it. If I don't specify it as final, then actually, let me just write this twice. And so non-final means you can change it. So we're going to use that inside of a little anonymous inner class that we're going to define, and we can actually define that as a lambda inside Java. I'm going to write it explicitly as anonymous inner class to start with, and then we'll see how that gets modified into a lambda. So inside here, I'm going to call do something, and I'm going to pass in a new instance of some class that implements foo, and here are the details. And I'm going to implement the method there, which is this go function. And what the go function is going to do is we're going to use that x. So I'm going to say system.out.println x. And let's see, put a curly semicolon there. And what is the unhappy about now? Oh, I need to make that a static. There we go. Okay, so what we're doing is we're passing in a strategy, just like we were passing in that lambda, or passing in a function reference, to do something, so that do something can use it to replace a step. But let's look at what's happening with x here. If I explicitly said x is final, then what I'm getting inside of this anonymous inner class, x is a copy of the value of x outside. And what that means is whenever do something actually uses go, it's always going to use 10 as the value. Do something behind the scenes could start up another thread, wait 10 minutes, and then call go long after I've done everything else in main. That's a possibility here. So we don't know what the value of x is at the point it's actually running. And what they did in Java to make that a simple issue is say that you can only have this be a static copy of the value of x inside there. And what that means is that if I say int x equals 10, making it non-final, Watch what happens if after here I try to say x equals 20. Wait, that's not, oh, okay. Now notice up here, this is where I thought the error was going to be down here, but the error is actually inside the anonymous inner class. It says variable x is accessed from within an inner class. It needs to be explicitly final, like we said above, or effectively final. And what effectively final means is that you don't change it anywhere. So as soon as we change this, makes x non-final. If we don't have the above, x is effectively final. We don't change it and can be used. And that's the rule in Java. And this is something that bothered people quite a bit about Java because anonymous inner classes felt like closures. And the idea of a closure is something that captures its environment and can modify its environment. In this particular case, we're just making a copy of things. So an anonymous inner class in Java, or if we define it as a lambda, like this, you notice how the new foo is gray? If I float over that, it's going to tell me anonymous foo can be replaced with a lambda. So I'm going to say replace with lambda, and boom. We get the Java version of a lambda here, which is the parameters being passed in, and then what to do with those parameters. So we'll see in this particular case, it's fairly similar to what we wrote inside Kotlin, but it's still doing the same thing. X is, again, a copy of things, even though we're using a lambda. Now, if we go back over to our Kotlin version over here, what is going on with Z here? In Kotlin, oops, lambdas are closures. They capture and can modify their environment. So in a case like this, that Z could be modified by this lambda. I could actually come in here and say Z equals 100. And that's perfectly fine. And it will change the value of Z outside here. So I could then, if I println Z, let's run this guy. We'll see that the Z printed out as 100. So I actually modified that value. That means it's not locked down. And what's really nice about this, and potentially really dangerous if you're not careful, is let's say that do stuff actually started a coroutine. So it starts some asynchronous processing behind the scenes. And then at some point in the future runs this. At that point in the future, I've modified Z. Now, depending on how your programs run, that could be very, very dangerous. And there's some nice checks that it'll do based on things like if I test the value of Z and then assume its value, it might warn me. And we'll see that more when we talk about nullability, because that's usually where it hits. It's if you say if something is not equal to null and then use it inside a block, if that something could possibly be modified by another thread, the Kotlin compiler will warn you. And it'll say, hey, you've checked this, but by the time you get into the body, it may have changed. Maybe you check it, like if I said if Z, and this isn't going to work, but if Z is not equal to null, because it's not nullable, obviously. Well, I'm going to do this. Don't worry about that for the moment. I'm going to talk about nullability next week. Inside here, if I said if Z is not equal to null, and then inside of here, assumed it's not null and said println Z, trying to think of if I do Z plus 10. There we go. That'll do it. So if I do something like this, notice how Z has an error on it now. In a case like this, if I float over it, it's going to tell me smart cast to int without the question mark is impossible because Z is mutable. That's a var, right? And it could have been changed by this time. And so what this warning is telling us is, hey, we checked for null. That's great. But notice how there's a gap between there and there's time that could pass between the check and the use of it. And we're going to see this more when we actually do nullability checks. This is kind of a slightly forced example. But this is something that it does that's really a nice thing for us. It's trying to warn us that, hey, there's such a thing as multi-threading, and it could bite you in the butt here if you're not careful. So we'll talk about that more later. And I'm going to get rid of that null check here. That way things look good. So what's happening in here is the lambda knows about Z. It's a closure. Doesn't use a copy of Z when lambda defined, gets its value when we evaluate the expression. So whatever the value of Z is, at this point in runtime, it's going to get it. In the Java version, copied when non-inner class is created. So at the point of that creation, when we do this new foo, which is equivalent to the lambda here, all this lambda does is say new foo, define a go, and here's the value of that go. We copy it in as a hard-coded constant value at that point in time. So that's a big, big difference between Java and Kotlin there. Kotlin has closures, Java does not. So that's something to just be aware of there. Making you aware of that, it's really important because, again, if you use any type of multi-threading, which, in a lot of applications you're going to, that can make this really, really tricky because, you could be changing something in a different thread and it has effect inside here. So you have to be kind of careful about that. Okay, any questions about that? Okay, so we got a few more minutes. Let's see what my next thing I want to talk about. So high order functions, function types. One thing you can do that I'm not a fan of, but it is doable. Sometimes people aren't super keen on seeing function syntax written out like that. They really want it to be like a single type. You could define a type alias for this. So we could do something kind of like this and come up here and say type alias something doer equals that. So we could define something like that, and then an alternate version of this function could just say type doer. Something doer, not type doer. There we go. So we could do something like that. It does the same thing. I would really recommend you just get used to that syntax. Every once in a while, something might be clearer using a type alias, but you're going to see a function type syntax constantly, like all over the place. And I recommend you to get used to it, get comfortable with it, and use it. This type alias, it makes things, if you look at this, do something doer, it kind of looks like that's some kind of object. And technically behind the scenes it is when you're running this on the Java virtual machine. But I think it really obfuscates more than it helps here. So having that functional type and getting used to and comfortable with these, it takes a little bit if you've never done these before. But once you get used to it, parens with arguments, arrow, return type, that actually gets pretty usable there. Okay, so functional types, blah, 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 blah. We talked about spread. We talked about lists and arrays very briefly. We're going to come back to those in more detail. I think that pretty much wraps up what I wanted to talk about this week. I really don't want to jump into talking about recursion with 5 minutes left because I want to go into a few more details on recursion, and I want to try to see how comfortable people are with recursion because it's something that it's a really useful tool, and I know it can be a little scary sometimes. It's kind of weird thinking about a problem in terms of itself, but once you get used to it, you can do some really awesome things with it. So let's see, is that everything? I think that is everything. I'm just going over my notes. Yeah. Any questions on anything? Yes, there will. And once we're out of the class, I'm going to take a look at the assignment that I'd done previously, maybe make some tweaks to it, and make sure that I've covered everything that's needed for it. Um, my plan is basically each week is going to be an assignment, except for the midterm and the final. There's going to be a midterm on the 7th week and a final on the 14th week. And those will only be based on the content of the 6 weeks prior to each. And those are worth 15% of your grade. Um, the Each of them are worth 15% of your grade. What was I going to say? Oh yeah, for the assignments, basically the pacing sometimes changes from term to term. Sometimes I'll go down in the weeds a little bit more, and so I won't cover quite as many concepts, and so I have to kind of tweak the assignments from term to term. So I won't have the assignments posted before the class. After the class, I'll review it, make sure that the assignments look good, post them, and then you can do them. And the assignments are just 1 week assignments. So they're generally fairly easy assignments, but I do recommend you look at them right away, just because, especially when you get into some concepts like generics, that can be a little tricky to weed through. And for this week, if you're not familiar with passing functions as arguments, um, look at it fairly early. It's not a tough assignment, assuming I do what I did similar, but you're going to have to pass some functions. Any other questions? Cool. Well, have a great week and do well in the assignment. If you have any questions, post them in the forums, or if it's something much more deep in the weeds for your code, send me an email, and I will see you next week.